All right. So what I want to do, I just want to go through some of the formulas in Chapter 11 and just kind of go over some techniques, or just sort of recall how to work with some of the details of these formulas. And there's some things here I'll talk about, some maybe faster computational techniques. And I'll send an email out about that too. Let's take a look. So the first thing, and here, let me get started recording. Oh no, we're good, we're good. So the first thing I want to talk about here is what's called simple interest. And the idea of simple interest is this formula. This is what you're going to be doing. Now, simple interest breaks down like this. P is the principal. R is the interest rate. And T is time. Now, for these types of problems, for the most part, what you're going to get is an interest rate that's going to be annual. That means it's charged per year. And so time is going to be measured in years. So for example, let's say you borrow $2,000 at 5% interest for 10 years. And let's say we're asked to find the interest. So the interest it's PRT. Now P is going to be 2,000. R is the interest rate as a decimal. So you want to take this number and divide it by 100. Or take kind of the decimal point you would get here, move it 2 spots over. You get 0.05. And then time is 10. Let me get a calculator here real quick. Excuse me. Oh. And so we get 1,000. And there we go. So that's simple interest. Now there's a variation on this. Is sometimes we're going to get an interest rate that could be monthly. So let's say we have this. Let's say we borrow $4,000 at 3% monthly. For 3 months. Now, in this case, it's going to seem like really the regular simple interest question. Since this is monthly and we're dealing with 3 months, again, our time's going to be 3. You can think of it instead of maybe years or months. Time is the number of cycles that the interest is you're going to be having this loan or you're investing. So 3% monthly means we're having this for 3 cycles, 3 months. So again, and then again, divide this by 100, you get 0.03, divide that interest rate. And then this time 3 is going to be 3 months. So if we do this, we're going to get 360. And that's going to be our answer. Now, where this gets a little tricky is when we have an annual interest rate. It's charged once a year, but we only have the loan, or we only make the investment for a fraction of a year. So as long as we have an annual interest rate with years, we use the same formula. Or we have a monthly interest rate with months, we use the same formula. Where it gets a little tricky is when we mix annual with months. We mix years with months. And so that's where you'll see this version. So we have 7.2% annual interest for 4 months. So this is where it can get a little tricky. We have an annual interest rate. Remember the last example we had monthly, but we don't have it for 4 years, we have it for 4 months. So that means we have to convert the time into the same unit of measure, same unit of time measure that the interest rate is using. Now, so far, the interest rate and the amount of time, the units of measure have matched. So if we have an annual interest rate, we were borrowing for years. If we had a monthly interest rate, we were borrowing for just months. But now we have an annual, but we're borrowing for months. So what we do is we have to convert these 4 months to years. So you could do it this way. 1 year equals 12 months. And just multiply it. And you got that invisible one there. If you multiply across, months will cancel. And so we get 1/12 of a year. Or if you want, you can just take the number of months and place that over 12. That'll work just as well. I'm sorry, not 1/12. I'm sorry. 4 12s. There we go. 4 times 1 is 4. 1 times 12 is 12. So the interest would be PRT, 700, times our rate. And again, divided by 100. Multiplied by 4/12. And so what we get. Now in the calculator, you can type in 4/12 as, I'll put a parenthesis, 4 divided by 12, close parenthesis. And it comes out to $16.80. So those are the variations on just simple interest. Now what we'll typically do though, is we'll ask about the simple interest plus the original principal. What's the total? So for example, if you're borrowing money, you have to pay back not only the principal, but of course the interest you've earned. So that formula is A equals P plus I. The total is going to be principal plus interest. And we know the formula for interest, it's PRT. So any of these formulas are going to work. But then we can factor out the P. And this is that formula they get in the text. And this is typically the preferred one, but you could use this one too. This one might be a little vague, but this is a good one. So we might ask for something, say, when we look for this, we call this the maturity value. So when we have the principal plus the interest, it's a maturity value. an example like this, let's see, hold on one sec. There is a difference. Let me see. So there is a slight difference here. When this is a loan, where we have to pay somebody back, it's called maturity value. But if it's an investment, it will be called future value. So maturity value is what we call this when we borrowed some money and we're going to pay it back. Future value is when we've invested and we're going to get our money back at some point. So you'll see them referred, you'll see it used, but ultimately what you're going to do is use the same formula for maturity value or future value. So someone might ask, what's the future value or the maturity value if we have a situation like this? So let's say we borrowed $10,000. So since we borrowed it, we're going to be paying it back. This would be a maturity value. So this is annual interest. And I should also mention, if they don't say annual interest, you can assume it's annual. If they do monthly interest or daily interest or something like that, looking at the homeworks, they'll tell you that. If they don't say anything in the homeworks, you might have noticed, we assume it's going to be annual. So we have annual interest for 6 years. So we could use this formula. So P is 10,000. R, again, divide that by 100, we'll get 0.0262 times the number of years, which is 6. That's our T. So let's see here. 1 plus 0.0262 times 6. And then we multiply by 1,000, 10,000. We'll get 11572. So that'll be our answer. Now to find the interest, they might have you calculate a maturity value and then ask, okay, well you've got the maturity value or you have the future value. And how much interest is that? And so the way you find interest, remember, A is the sum of the principal plus the interest. So we want to solve for A, and if you solve for I rather, and if you do that, subtract P from both sides, the total minus the principal, that's going to be your interest. So if we have the future value or the maturity value, we can find the interest by taking the total we just found, subtracting from it the principal. Now our principal was 10,000. So we'll get A minus P equals I. And then what we'll get is 1,572 is I. And that's going to be your answer. So that's how you could find the interest. All right. So this is kind of an overview of section 1.1. Now there's something you do want to be careful with in here. Let me see. So It's the difference between exact method and ordinary method. And this has to do with how many days you consider to be in a year. So with the exact method, we could say that a year has 365 days. But for the ordinary method, a year has 360 days. So it's something you want to think about. Now, usually they assume the ordinary method in chapter 11. The previous chapter, let's see, chapter 10, we would use this, but now we're going to be using this. If there's any issues with that, let me know, but this should be the default. So I'm going to move to section 11.2, and this is compound interest. And for compound interest, we have that formula. And then our P, it's going to be the same thing. P is going to be the principal. R is the interest rate. I'll abbreviate interest. And again, you've got to convert this to a decimal. So whatever percent they give you, or decimal form. And so you take the percent and you divide it by 100, and that will give you the full decimal form. N is the number of times compounded. And T is time, usually in years. Now with compounding, you want to recognize what N could be. It's based on sort of the language. So if the interest is compounded annually, now it's going to be an annual interest. You're going to get annual interest rates, and they might say that. That's just describing the interest rate, as opposed to being monthly or daily. But compounded, it'll say compounded is something that will be mentioned specifically. And so with a compounded interest here, what we're going to be doing is taking an annual interest and charging a fraction of it throughout the year. So if you see semi-annually, if we're compounding semi-annually, that's twice a year. N will equal 2. If you're compounding quarterly, that's 4 times a year. N is going to be 4. If you're compounding monthly, N is 12. If you're compounding daily, usually we're using the ordinary method. N will be 360. So, and then of course, A is our total. So let's take a look at an example. And then we have some applications for this. The idea of present value we'll look at. And then there's inflation. Let's take a look here. And then we have yield. What we call the percent yield. And it's finding, percent yield's finding an equivalence between compounded rate and the simple interest rate. But let's take a look, just using the formula. Let's say we have this. $25,000. You could be borrowing it, we could be lending it, or investing it. Let's say if R is 10%. That means you got to drop the percent by dividing by 100, so we get 0.10. Compounded quarterly. So that equals 4. And we're going to do this for t is 12 years. Oh, I'm sorry, this is not A, this is P. Principal, that's what we're actually investing. We're going to find A. And again, the T for this is usually going to be years. All right. So the formula, it might help define this first and define that. So R over N, 0.10, and this is quarterly, so we're dividing by 4. That should be 0.025. And then NT, that's going to be, let's see, 4 times 12, or 48. So we get A is 25,000 times 1 plus 0.025 to the 48. So what you want to do in this calculation, you want to do it in the parentheses first. Then once you get a number here, apply the exponent. And then once you get a number here, after applying the exponent, you multiply last. So you add first, use the exponent, at the end, multiply. And I'm going to use as many decimals as my calculator will spare. Or as many as my calculator can handle. So multiply that by 25,000. And we get 81,787. And then we need to round to the hundreds place. So that's the tenths. That's the hundreds, that's the thousands. So we take this number, we look at the digit behind it. If this digit is 5 or greater, this will be a 4. If it's less than 5, this stays the same. But since it's 5 or greater, we'll get this. So the reason we do this with money is that we always round to the nearest cent. This is the nearest 10 cents. This is the nearest dollar, nearest 10 cents, nearest cent. We always want to round to the nearest cent. Now, someone might ask, well, okay, but how much of this is interest? And so to find that out, again, we take the total, which is A, subtract the principal, and we would get the interest. So 81,787.24 minus the original investment was 25,000. And so what we'll get $56,787.24, which is a lot of interest. But this had a 10%, so it's going to be kind of high. So that's the basic use of the compound interest formula, your first use of it. Now, what we're going to look at, there are applications of it. And I do need to mention Not so much an application, but another side of it. And it's what's called present value. So the idea of present value is we solve for P to get this. And so this is the formula for present value. So what do we use this for? Well, present value is when we want to find out if we have a goal. For example, let's say we want to have $10,000 in our bank account, and the interest rate is 5%. It's compounded, say, monthly. We're going to do this for 5 years. Well, if we're going to get $10,000, how much do we need to invest today to get $10,000 in this account 5 years from now? So it's about, okay, well, if I have a goal, what do I have to invest now? So let's say we have a goal of $10,000. And then we have the account is 5% for 5 years. And again, we're going to assume this is an annual percent. And let's say it's compounded monthly. All right. So in this case, our goal goes on top. 1 plus, and again, R, divide this by 100, 0.05. We're compounding monthly, so that means N is 12. And then we have to the NT, or 12 times. We're doing this for 5 years. And that's how we're going to compute our present value. And the present value is going to be smaller than the goal. So what do we get here? We have 10,000. 1 plus, so it's 12 divided by 5, or 5 divided by 12. And again, I'm going to use as many decimals as I can get in here. And NT, that's going to be 60, or 10,000 over this number. To the 60th. Let me check something here real quick. Oh, shoot, sorry, I made an error. There's some zeros here. 0.004. And then that's better. So there's some zeros in here. Let's see, 1.0041, 1, 2, 3, 4, 7. Raise that to the 60th. And that's a little better. It's a pretty big number here. And take this, divide 10,000 by it. And so what we'll get is $7,792. And again, you got to round to the nearest cent. It's going to come out to 5 cents. So, in other words, if we deposit this money 5 years from now, we're going to have $10,000. So this is what we need to deposit today in the present to reach our goal in the future. All right. So that's one sort of application of this. Now the other one's inflation. So the idea of inflation is this. We're going to let n equal 1. That's a huge thing with this. We're going to let n equal 1. So in essence, what our formula will become if we let n equal 1, we're basically going to get that. Because 1 times t is t, r divided by 1 is just r. So in essence, that's what we're going to get with inflation. Now, let's do a problem here. So let's say your salary is $40,000. In 2015. And inflation rate is 7%. So what do you need to earn to have the same purchasing power? So what that means, inflation is that the prices of things are going up. So that means if something costs, say, $5 in 2015, you know, it could cost, say, like $6 or $7 in 2021 or something. So basically, the price of things are going up. And we need to make sure, we hope that we have a salary, some kind of pay raises, increases that keep up with inflation so we can afford to buy the same things, even though the prices are getting more expensive. So again, we use our formula, but again, we're going to use n equals 1. And for the interest rate, we're going to use the inflation rate of 7%. And then for our P, we're going to use the amount of money in 2015. Now, we're talking about a salary here. This could be like a $10 bill, it could be rent, it could be anything. But whatever this sort of value is here, that's going to be our P. So you have 40,000, 1 plus, and again as a decimal to the n times. And then it's 5 years, because 2020 minus 2015, 5. And I guess this is the formula we get, what we saw. 1 plus r is a decimal. And then here's t, because 1 times 5 is 5. 0.07 divided by 1 is 0.07. And so we'll get this. And then now we apply the exponent. I'll use as many digits as I can. And so what we'll get is 56,102.07. And again, rounding to the hundreds place or the nearest cent. And there we go. So if the inflation rate's 7% per year, and we're making 40,000 in 2015, to buy the same things in 2020, we need to be making 56,102.07. All right. So the last application of this is the percent yield. What's called the effective interest rate. And the idea is this: we want to take this compounded interest rate, because this could be hard to imagine. So it's compounded so many times a year at 5% annual rate. It's a little easier to imagine simple interest. So we want to take this compounded interest and translate it into simple interest. So the way we do this is for effective rate. Is we're going to still use our formula. But instead what we're going to do, we're going to let t equal 1 and p equal $100. So for this type of problem, they ask about effective interest rate. T is going to be 1, p is going to be 100. So let's say we have a problem like this. Let's say we have 3% compounded daily. Now, compounded daily, well, first, our R is going to be this divided by 100, 0.03. Compounded daily, unless they say to use the exact method, we assume the ordinary method. So that means daily will be 360. And so, again, we're going to use P is 100. And T is equal to 1. So we have A equals P, 1 plus R over N to the NT, or 100, 1 plus 0.03 over 360 to the 360 times T, which is 1. So this is 100, 1 plus, and then let's see, 0.03 divided by 360. Put this here. And this will be 360 times 1 is 360. Or 100, 1.00008, 360, or 100, let's see, times 1.030. 453,246. And this will come out to 103.04. We'll round to hundreds place. So how do we figure out the effective rate? Well, we subtract 100 from this. Remember, 100 was our principal, and we get $3.05. And this is the same as an effective interest rate of 3.05. And so that's it. So basically what we've done is we took our 3%, we took our compounding, and we applied it to $100. Now, 3% with simple, and we did it for 1 year. Now, 3% with simple interest for 1 year, and it's compounded annually. Well, if you have $100, you'll get $3 in interest. 100, which is your principal, times the interest rate, which is 3%, 0.03, times t equals 1. So you'll get $3. So now we apply compound interest to $100. And we actually get $3.05, which is 3.05 of 100. The reason we let P be 100 is the amount over 100 automatically is our percent. So that's the effective interest rate. It's 3.05%. A little bit more than the simple interest rate. If we had a simple interest rate of 3%, we would get $3 at the end of the year. With a compounded 3% interest rate, we get $3.05 at the end of the year. All right. So we'll move on to 11.3. And average daily balance. Let's sort of do a kind of a quick example with this. Let's say you have an account. And this is say like a credit card balance. So let's say you have, say, April 10. April 10 to April 20. Your account balance is $400. But then on the 21st, we say we spend some more money, and it's 400. Let's say we're up to now $550, and we carry that with us all the way to, let's see, let's go April 24. So not too far. And then April 23. And on April 24, all the way through May 9. Well, on April 24, we make a payment of $250. And so that has us at $300, and that's what we owe on our credit card all the way to the end of the billing cycle. So what's going on here? Well, the number of days here, and again, the way you could do the number of days is you do the date, 20 minus 10, and then you add 1. And so you've got, because this is inclusive, we include this day, so you'll get 11 days here. And then from here to here, let's see, you'll have 3 days here. And then from here to here, let's see, what do we have? Got 16 days. This one could be a little tricky. You could say April 30th minus the 24 is 6, add 1 is 7. And then you would do May 9th to May 1st. And subtract, 9 minus 1 is 8, plus 1 is 9. And then the 7 plus the 9 would give you the 16. So well, you could break that down. April has 30 days in it. So you could take the 30th minus the 24 plus 1, that'll be 7. And then for May 9th to May 1st, will come out to 9, and then 7 plus 9 will give you 16. So this is how we can do this. Once we have the number of days for each balance, we're going to have 400 times 11. See if you can see that. I think you can. Plus 550 times 3 plus 330, or, oh, I'm sorry, this is 300. Ooh. Sorry, that last one's 300. 300 times 16. So the balance and the number of days, you had that balance. Balance, number of days, you had that balance. Balance, number of days, you had that balance. And so that'll give you the sort of the total, if you will. So this will be 4,400 1,650. That's 300 times 16. 4,800. That's $6,890. So what we want to do is take this total, divide by the total number of days. Now the days, we have 11 plus 3 plus 16, and that's going to be 30 days. So to find the average daily balance, divide by 30. Take the total, divide by 30. And so rounding to the hundredths place comes out to $229.67. And so that is your average daily balance. Now, what this is used for is coming up with what they call like a finance charge. So if you're late making a payment, they're going to ding you for it. So they're going to ding you based on your average daily balance. Let me check the numbers here real quick. Ah, I've got a mistake. I'm sorry. Go back here. I made an error. 4,400. Okay. 550 times 3, 1,650. 300 times 16. 4,800. 400. There. Sorry. Made a mistake. Yeah, that looked a little low. Something about that didn't look quite right. So divide this by 30. So we get 361.67. All right, that looks better. Got it. Sorry about that. All right. These needed to be added correctly to get this divided by 30. And there we go. So what will happen is, let's see here. How are they describing this finance charge? So let's see, what are they calling the interest rate? There's an interest rate here. They might just call it interest rate. Let me just double check. And so they'll say the interest on the average daily balance. Let's say the interest is the average daily balance. Let's say it's 1.5%. So you missed a payment, so they're going to give you a late fee. So it could be late fee or finance charge. So what they're going to do, they're going to charge that against your average daily balance. So if the interest on the average daily balance is 1.5%, and you're going to get this late fee, you use the simple interest formula, where P is the average daily balance. That's the interest rate on the average daily balance. And we're going to usually let T equal 1 for this problem. So our fee, even though it's the interest formula, 361.67 times, and again, divide that by 100, you get 0.015, and then multiply by 1. And so rounding to the hundredths place, we get 5.43, and that's it. So let's see. Now they talk about APR, and again, the formula they use for APR, I'm not exactly sure how they came up with this. But the idea is the annual percentage rate is what we're looking for. And it turns out to be this. APR's annual percentage rate. And so it's equal to, or approximately, 2 times N times R over N plus 1. And then R is simple interest. And then N is the number of payments. So R is the simple interest rate, and N is the number of payments. Now, what's important about this is you don't see anything about the money you're borrowing or the money you're lending. That doesn't come into this calculation. And very often in these problems, they'll give you that number, and you're like, oh gosh, how do I use this number? But for this, you don't need it. So let me give you an example. Pick a homework problem here. So let's say you have this. Let's say someone borrows $4,000. At 8%. And they're going to tell you it's simple interest. And let's say they're going to repay the loan in 6 equal monthly payments. So they borrow $4,000 at 8% simple interest. There are 6 equal monthly payments. So this means N is 6 and R, which is 8%, again divided by 100, it's 0.08. And so we plug these numbers into that formula. So the APR approximately is 2 times 6 times 0.08 over 6 plus 1. Or, let's take a look at that. We get 0.137142, and there's some other digits. So we want to, this is the decimal form of our percent. We want to multiply this by 100, and we'll get approximately 13.7% is the APR. All right. So the big formula in this section and in 11.5, and this is the monthly payments formula. It's an APR formula, and it's this. Monster formula. You want to divide and conquer with this. So let's say we have a problem where you borrow, say, $10,000. And let's take a look at a question here. Let's see if they call this interest rate. So they might call it annual interest. They might just call it that. So let's say we have this, get it at, say, 7% monthly. So monthly, that means your N's going to be 12. That tells us how often it's compounded. So it's compounded monthly for 10 years. So what I recommend is this. Find R over N, and then find NT. So A is how much we borrowed, 10,000. R is this divided by 100, or 0.07. T is going to be 10 years. And then N, this is monthly. So N equals 12. So N over R, or sorry, R over N. That'll be 0.07 divided by 12, and we're going to get a bunch of decimal spaces. We're going to get that. And then NT, you can see that, okay. That's going to be 12. We're going for 10 years, or 120. So we're going to put all this together. And again, this could be kind of a tedious calculation, but you know, do your steps carefully. So payment equals, then we have 10,000 here. R over N is going to be this. And then NT is minus, well, NT was 120. This might be kind of hard to see. I don't know if you can see that, but we have minus 120 here. Let's see if I can scoot that over a bit. So you have minus 120. Now, we want to make sure we add the 1 first. We're going to work here, then apply the exponent, do the subtraction last, at least for this bottom part. Now, I'm going through all the steps. You can have, there's different ways of breaking up this calculation. So you don't have to keep writing the same things over again. I'm just going to go through everything as if that's what we're doing every time, just for the sake of completeness. But I mean, if you have a shortcut to do these calculations, go ahead. Well, now we need to take this number and apply to it that exponent minus 120. This up a little bit. Divide these, oh, we'll do the subtraction. And now, once we've gotten the top and the bottom into just numbers, there's a number here and a number here, now we can divide at the very end here, or close to the very end. And so we get $583.98. So that's the monthly payment we're going to pay for, let's see, we were looking at 10 years, monthly payments, the payback 10,000. We're going to pay $583.98 per month. Now, one of the questions they'll ask you in these is this. I'm just going to write down our data. This was $10,000 at 7% for 10 years. Let me just double check here. Double check this real quick. And xy negative 120 is that. 1 minus that. Oh, shoot, I forgot a 0 here. My bad. I'm sorry, I think I made a mistake. Let me back up here a little bit. I made an error here. Let me back up. I might have missed something here. Pardon me for just a moment. I'm going to redo this calculation. I'm going to redo it piecemeal. So I got my 0.07 over 12. 1 minus 1 plus 0.07 over 12 to the minus 120, or the minus 12 times 10. So if I do 0.07, sorry, I apologize, I think I made a mistake. What I'm going to get is 0.0058. 1, 2, 3, 4, 5 of those to the minus 120. And that's going to go up here. All right, no, I definitely missed a 0 up here. We're going to add 1 to this. If we add 1, we get that. Now we take this number, we raise it to the minus 120. So we do get something different. And so if I do that, the decimal I'm going to get is 0.497596. So here, let me go through it again. I apologize. I missed a digit there, and then. So if you're copying down notes, let me run through this again. I apologize. I made some kind of an error in here. So R over N, again, you want to calculate that first. Minus 120, and there we go. Double check my numbers here. All right, that's correct. Add 1 to this. So it's easy to make a mistake with this one. You want to be really careful. All right, so this is looking a little more, I think this is more correct. Now there's another hazard though, as I keep copying these numbers, you can accidentally make a copy error as you go. And so once you get it right the first time, that might be, you could erase things as you go. Now I'm doing it stepwise like this just to show you all the steps so you can write them down. But what you could do is you could erase this, have 1 plus, then erase all of this, put this number there. And you could do that also, so you save time not writing everything down, and it does avoid a copy error. All right, well, I'm going to keep going. Here we go. All right, here we go. We multiply this to 10,000. All right, so we get $116, and rounding to the hundreds, 11 cents. So that's the monthly payment. So we're going to pay this once a month for 10 years to pay off the $10,000. Whew, so I'm going to put that up here. So one of the questions they're going to ask you is, well, how much do you spend in total over the 10 years? So the total, this isn't a formula in the text, but it's the payment times N times T. That's going to give you the total paid. Or 116.11 times 12 times 10 . And so what you end up getting is $13,933.20. So that's how much you pay over 10 years. Now the interest, they might ask you how much of that is interest. Well, the interest I is going to be the total paid minus the principal. And that's going to give you the interest. So it's going to be 13,933.20 minus 10,000. And that'll come out to $3,933.20. So that's how much is interest. All right. So one of the questions that might also come up, though, is paying this off. So let's say after 5 years, this person decides to pay off the what they owe. They don't want to go the full 10 years. So the payoff formula is going to be this. it's very similar to the payment formula. And what's going to happen here, we want to find U. In U, that's remaining payments. U is remaining payments. So to find out the remaining payments, we want to find out how many years are left. Times n. Again, n is going to be 12. So let's say we're going to pay this off after 5 years. So the original loan amount was going to be paid off over 10 years. We're going to pay it off 5 years early. So what's the difference between when we pay it off and when we were supposed to pay it off in the future? It's going to be 5 times 12, or 60. And that's going to be our U. So we plug in our numbers. And then our R over N, that was 0.0058, some 3's. To the minus 60. .0058333333. And so to figure this out, we had to use the payment that we calculated from before. So we have to have this calculated in order to use this payoff formula. So we do this calculation again. Got the number of zeros right. Okay. So now we get this. And so we get 5,863.79. So after 5 years, if we send this to the bank, we can pay off our loan. Now, do we save money doing this? Well, we do. So the way we can figure it out is this. We're making 12 payments a year for 5 years, for the remaining 5 years. Originally it was a full 10, but we're not only going to do it for 5, so we're going to miss out on 5 years of payments if we pay it off right now. So what you want to do is compute how much money you would have paid starting for the last 5 years, the remaining 5 years, if you paid during those 5 years. So remaining pay well, that's going to be the payment times U, because U is how many payments were left, and payment is how much you're making on, or how much money you're paying on each of those payments. So 116.11 times 60 we get 6,966.60 cents. So if we decided to continue paying for the remaining 5 years, well, there's 60 payments in that 5 years, this is how much we'd be paying. But if we pay everything off now, this is how much we're paying. So how much are we saving? What's going to be what we would have paid minus the payoff amount. And so we would save $1,102.81. And so that's how much we're going to save if we pay everything off now. All right. So that section, I'll move on to the next section. We'll go to 11.4. And 11.4, it's about stocks and bonds. So one of the questions they'll ask, so stocks have what are called dividends. This is how much money a stock makes. And so what you might ask is this. Let's say you have a stock with a dividend of $1.21, and you have 400 shares. Remember, a share is a way of measuring how much stock you have. It's like we use inches to measure distance. We use pounds to measure quantity of weight. We use shares to measure the quantity of stock. So let's say you have 400 shares, and the yield is $1.21. That's money that you get per share. So how much do you get in total from these shares? This is the yield. So what we do is we take the $1.21, we multiply by the 400 shares, and that's going to get us the total yield. And that comes out to $484. So that gives us the yield on this stock, or the total yield for all the shares that we own. Now, another thing is called the percent yield. And this is a little different, or the dividend yield, rather. And I use a different formula from the text. You can use the simple interest approach, But what I'm going to do is this. I'm going to call this, let's see here. It's the yield over the price times 100%. That's your dividend yield. Yield divided by price times 100. So let's say we have this. We have our stock is a $1.20 yield per share. And each share has a price of $12. And so we would want to find a dividend yield. So what we do is we take the yield, 1.20, divide by the price, $12, times 100. And if you do that calculation, you'll get 10%. And that's going to be your answer. Now, I'm going to skip the part on the chart. There's a lot of stuff there. They do have some examples on how to do that, like example 3 talks about this. But there's a whole bunch of problems you can get out of that chart. Just for the sake of time, I'm going to move on. But example 3, parts A and B, they give you an idea of some of the questions they'll ask. Now for bonds, let's see here. Well, we'll do one question from there. Let's say we have this. Let's say, and I'm going to use the chart they have here. Let's go with Apple. And let's suppose someone buys Apple stock. They purchase 562 shares at the 52-week low. And let's see, the 52-week low is $92. And then they sell at the 52-week high. What is their profit? So the 52-week low, the low is when they bought, and that's at $92. And let's see, I'll insert this here, bought. And then the high, let's see here, for the Apple stock, 134.54. And we have 562 shares. So one way they do this, and the way they do this in the text, you could come up with maybe a simpler way. But the value of your shares, we'll go with the text method. It's the number of shares times the price. So number of shares times the price. Let's write shares here so we remember it's 562. for the low value, and this is what they were bought at. They bought at the low value. So that's going to be $562 times $92 for $51,704. Now for the high value, or the what we sold at, that's 562 times 134.54. And that's what you're going to get. Now, if you have a profit, what you always do is you take the amount sold, subtract the value bought. So value you sold at minus value bought. And the number we get from this, if it's a positive number, it's a profit. If it's a negative number, it's a loss. So we take 75611.48 minus 51704, and what we'll get $23,907.48. And because this is positive, it's profit. So that would be a problem you would have for the stocks in the stock chart section. All right. So the next question you're going to have is bonds. The next kind of thing with bonds is it's really knowing the vocabulary of bonds. So the face value of a bond is what you paid for the bond. It's like the principal. The coupon is the interest rate, and the maturity date is going to tell you your time T. When we work with bonds, we use the simple interest formula. So P is face value. R is the coupon, and again you've got to convert it from percent form to the full decimal form. And then T is going to be, it's going to be our maturity date. Usually that's an actual date, but it'd be years to maturity date. But I think in the text they'll just sometimes call it maturity. Like a maturity of 10 years. So that means if you subtract the maturity, if you subtract our date from maturity date, you're going to get the maturity of 10 years. See, that was it. So that's the key thing to remember. Face value, coupon, your maturity. So, or they might not even use the term maturity. They might say maturity date. They might actually call this the maturity date. Looking at the example here. All right. So let's say you have this. There's a bond with face value of $10,000, coupon of, let's say, 3% and a maturity date of 10 years. And so they might ask, what is the total interest you're going to be paid? What's the total interest? And again, we're going to use simple interest. So we use the simple interest formula. So P is 10,000. R is 0.03. Again, we take 3%, divide by 100. And then T is going to be 10 years. So we get $3,000. And there we go. Double check. Okay. Oh, I did double check something here. Yeah, we're good. We're good. So that would be the interest paid, or the total interest paid. All right, so what happens with the bond is you'll get your money back and also this interest. All right. So the last thing I'm going to mention in 11.4 is the net asset value of a mutual fund. And there's a couple calculations you do with this. So net asset value, NAV, it's assets minus liabilities over the number of shares. You can see that. I think you can. So let's say we have an example like this. Let's say the assets are 11 million. The liabilities are 500,000, and let's say there are 20,000 shares. Now this problem's a little problematic because we have 11 million for assets and liabilities. So you have to do 11 million subtract 500,000. Now because the magnitudes are different, we want to express these as the numbers they represent. Now this one's already done for us, that's 500,000, but 11 million what's going to be 11 times 1 million? Like so. So that's 11 million. So we calculate the NAV. We have our assets, the value of our assets, minus our liabilities. So 11 million minus 500,000 divided by 20,000 shares. If we do that calculation, we get $525. So that's the NAV. Now, another question they'll ask is, let's suppose we have $10,000. So a part B question is, how many shares can we buy for 10,000? So how many shares can we buy for 10,000? Now what happens here is the NAV is kind of the average value per share. Once liabilities are taken care of, this is the average value of the shares. So we want to find out how many times this goes into 10,000, the amount we want to invest. Now remember, NAV, it's used with mutual funds. So we're calculating sort of the average value of a share in a mutual fund, and then we're going to invest $10,000 into that mutual fund. If we do the division, we get 19.0476 and some other digits. But we're always going to round down to the nearest share. We always round down. Even if this was 19.98, we still round down to 19. And the reason is you can't have a fraction of a share. You either buy the whole share or you don't. So we'd be able to get 19 whole shares is what we'd be able to do. Well, the last thing I want to do, I want to go through an example with home ownership, 11.5. And so the idea here is this. Let's say we have a piece of property that's $100,000. There's a 15% down payment. There are 2.5 points and a $300 bank fee. And let's say if we mortgage this property, let's say it's a 6% mortgage interest rate. Here, let me write this down so I don't forget. Give you a second to write that down, if you want to. All right, I think I got it. Okay. So I want to start from the top. First off, we want to figure out what do we have to show up to the bank with? Well, we have to show up to the bank with our down payment and our closing costs. Now, closing costs are the points and the bank fees. The 6% mortgage interest rate, we're going to deal with that later. So first off, the down payment. I'll abbreviate that DP. The down payment is the down payment rate times the price. That's going to be your down payment. So for us, that was 15%, so 0.15. Again, take 15%, divide by 100. Times the price of 100,000. And so that's going to come out to $15,000. So this is the down payment. Now, next we need to find the mortgage. I'm going to put this off to the side here. DP was 15,000. Now the mortgage, we're going to need this mortgage for a couple things. That's the price minus the down payment. You have to subtract the down payment first to get the mortgage. And so that'll be 100,000 minus 15,000, or 80 5,000. So I'm going to put up here that the mortgage, I'll call it M, is 85,000. Now, we're answering this question, how much do we need to show up to the bank with? And let me get a different pen here. That question is, we have to show up with the closing costs and the down payment. Well, we've got the down payment of 15,000. We now need to get the closing costs. So we have to start with the 2.5 points. Let's make this a decimal. It's 2.5 points. And the points, they're the same as a percent. So 2.5%. Now 2.5% of what? Well, it's 2.5% of the mortgage, not 2.5% of the price, but of the mortgage. So to get the points, it'll be the points rate times the mortgage. Or in this case, be sure you can see that, okay, 0.025, again, we have to divide that by 100, times the 85,000. And so we get 2,125. So that's the amount due to points. And points involve all kinds of different fees in processing and things like that. Now for closing costs, this is points plus bank fee or fees. And this is points as a dollar amount, not the percent. Points dollars. So we'll take the 2,125 plus the 300 for the bank fee. And so the closing cost will be 24.25. So that's our closing cost. So the down payment's 15,000. The closing costs are 2,425. So how much do we need to show up to the bank with to purchase this property? Well, it's going to be 15,000 plus 2,425 for 17,425. So down payment plus closing costs, $17,425. If we show up to the bank with that, we get to have this property. Great. But what about that other 85,000? Remember, a down payment's just a fraction of the original price. What do we do with the rest of the 85? Well, we have to pay that off. Now, to do that, we got to come up with our monthly payment. And again, it's going to be that same formula from 11.3. Now let's say we're doing a 30-year mortgage. Let me double check. 425. I'm just double checking my numbers here. Okay, good, yeah, we got it. So, to pay this off, let's say we have a 30-year mortgage. So we're going to use that payment formula. Now let's say we have a 30-year mortgage. That means we're going to make monthly payments for 30 years. They'll usually tell you it's a fixed interest rate. That means the interest rate won't change over time. Now for this, the interest rate for the mortgage was 6%. So again, let's get R over N. So first off, A is the mortgage, not the price, but the mortgage, how much we still have to pay off. R, it was 6%, or 0.06. N is going to be 12 times a year of monthly payments. And we're going to do this for 30 years. So first off, R over N. And again, we convert it to a decimal. NT, 12 times 30. $360. And so now we do our calculation. And there we go. So again, I'm going to go through this stepwise. Let's see, 1.005 to the minus 360. $0.166041928. Double check that. Okay. .005 divided by 0.833958072. And there we go. $509.62. If we round up, or round to the nearest cent. So we've got our payment. So I'm going to put that up here, more data. Monthly payment, $509.62. So the question, again, they'll ask, how much is this going to be over 30 years? And again, the total is payment times N times T, or 509.62 times 12 times 30. And so what we get is $183,462.20. Oh, 63. Okay. So that's how much we're going to pay out over 30 years. Now, how much of this is interest? Well, the interest will be the total minus, in this case, the mortgage. The mortgage is the same as our principal. So total minus mortgage will give us the interest. So that means $183,463.20 minus the mortgage of $85,000. Because we're only paying interest on the mortgage. We're not paying interest on the price. Once we've given the bank that down payment, we don't pay interest on it. But we are paying interest on the mortgage. This is what we have to borrow. So if we take that total, subtract 85,000, wow, $98,463.20. The interest we pay is actually greater than the actual mortgage. So that's a lot. So I'm going to record this total. 183,463.20. Now again, and then we've got our monthly payment. Let's say we look at this and we say, yikes, that's a lot of money. We're paying more interest than we are paying back the mortgage. Let's say we want to pay this off after 10 years. So again, what we're going to do is the payoff formula, which in this case is going to be payment. This will be 1 minus 1 plus R over N to the minus NT divided by R over N. Oh, I'm sorry, not NT. Let me go back. It's U minus U. So this is not NT. It's minus U. And again, use the number of payments left. So the years, let's say we're going to pay this off after 10 years. Well, this was a 30-year mortgage. So the years left, if we pay it off after 10, will be 30 minus 10, or 20. So after 10 years, we're going to have 20 years left. And so U is going to be years left times N, or 20 times 12, or 240. So that means U, it's the number of payments that are in that 20 years. We're going to try not to have to pay this thing during. We're just going to pay it off after 10 and then not have to pay it anymore. We're done. That means we get out of 20 years of payments, and those 20 years of payments they contain 240 payments. So that's our U. So now going back to this, monthly payment, well, that was let's see, it was $509.62 times 1 minus, and then R over N, we had that from before. It's 0.06 divided by 12, 0.005. To the minus 240 over 0.005. So we do the same process again. Now you might have some numbers here you can use. You don't have to do the calculation from scratch. If you have those, certainly go ahead. They'll save you some time. Just make your life easier too. So let's go to the negative 240. And so what we'll get, well, actually, no, we won't be able to reuse numbers here because we have negative 240 instead of negative 360. So we do have to calculate this one from scratch again, at least with the exponent. Again, before it was negative 360, negative 240 this time. Now, an interesting thing to note here, if you look at this number, to compute the remaining, well, we'll get to this in a bit, but remember that the remaining payments we had were $240 for the next 20 years. So you to find out how much money that is, we end up paying over that remaining 20 years. You take the monthly payment times the 240 payments. But now we've got a monthly payment times 139.58. That's going to be a lot less. So let's see what this turns out to be. This one. And so what we get is $71,133.15. So that's the payoff amount. Now, the question we might ask is, how much are we actually saving here? Well, remember, if we pay this off after 10 years, we don't have to make any more payments. And the number of payments we miss are 20 years worth of payments, 12 payments a year. So that's 240 payments. So in that remaining 20 years, we would have had to pay $562 times the number of payments times the 20 years, or $509.62 times 12 times 20. And so that comes out to wow, $122,308.80. So if we pay off this loan for 10 years, over the next 20 years after that, you still have to go $122,000. But if we pay it off at 10 years completely, the payoff amount's only $71,000 approximately. So how much do we save? Well, we take what we would have been paying over 20 years minus the 71,133.15 or 71,133.15. And so we save a whopping $51,175.65. So if we pay it off 20 years early, we save over $51,000. And that's it. That's it for the review. So if you have any questions, let me know.